Okay, so this video is going to show you how to use Desmos to do certain parts of the activity today. You don't really need it until you get to the second part. So you got to go to Google Classroom. I give you this data. You're gonna just highlight these two rows and copy them into Desmos. But I'm not going to use this data because then I would just be doing everything for you. So I made up another data. I found this online. This is blood alcohol content, and this is the risk of crashing your car. So it's going to show us how alcohol makes you more likely to get into an accident. But here I pasted it in, and then that's looking good. You're asked to do a scatter plot, so sketch this in that little space you have. Not my graph, yours when you do this. So let's see. One thing you want to check is the column names, so x1 and y1, that's the default values, but if you've already made another table in Desmos, sometimes it does x2 or y2, but these are the default, so we're going to use those. Now, it wants us to do a least squares regression that fits a line to the data. So least square regression is just the computer method that's used to find the equation, the model equation that fits the data the best. So we're going to fit a linear model, which looks like this, AT plus B, by typing it in this format. So going to go over here and type that in, y sub 1. And then you use the squiggle. I think that's called a tilde. A x sub 1 plus b. So here's the line that fits the data, and it was never gonna look like a good fit because you can see the data's curved, but this is a straight line. We'll tell Desmos to do the best it can anyway. And what we see over here is, well, first you have to type it in like this. It has to be y1 and x1 because these are referring to the names in the table. So this is the only way that it knows to use the data points. And then you use a squiggle here because that tells Desmos that you want to do a regression. You want to do a model fit in the first place. So it's going to do its best to fit the line to it, and it's going to come up with A, the slope of the line, and B, the y-intercept down there. Yep, so there's a linear model trying to fit the data. Now, you can tell it's not a good fit, but in AP Pre-Calc, the way that you're going to justify whether something is a good fit or not is to look at the residuals. So I clicked that thing there. Oh no, go in. This thing here that said plot, and then it put these points here. A residual is the difference between the model line and the data point. So for example, this data point, it's below the model line. So its residual is this dot down here. It's a negative. It's the same amount, just negative. But then this one up here is above the model line. So its residual here is positive. It's above 0. And the way that you justify whether a model is a good fit or a bad fit is to check whether there's a pattern in the residuals. So I can see that there is a pattern, like it's going down, kind of wavy, then it like curves back up. Like there is a pattern in these residuals. We don't want to see a pattern. We want to see something very horizontal. So that tells us this is definitely a bad fit. Now back to your thing, you write the model equation here. So you're just going to write this equation, but you're going to put your values for A and B in. That's all. Then there's some more questions for you to answer. You want to sketch your residuals, okay? And then it talks about underestimating and overestimating the true value. So if we go over here, for me, the model is overestimating if it is above the actual data point. So if the residual is negative, there's an overestimation. Over here, the model is below, it is underestimating the data. So a positive residual is an underestimation. so not a good fit. We're going to try a quadratic fit. Right, so you're going to do quadratic in here, and you'll write the equation. And then the next thing you'll do is do an exponential, and then write the exponential equation. So let's go over here and do that. So my quadratic will look like this. Remember, use y1 because you're referring to the table, and use a squiggle to tell Desmos that you are trying to do a regression fit. Do x1 squared plus b x1 plus c. Okay, there is the quadratic, and it does look better than the linear one. I got my parameters a, b, and c, so I would be able to write my equation at that point. Now I want to see, is this actually a good fit for me? So I'm going to click the residuals plot, and okay, same color, don't be the same color. To be red. Okay, so there we go. So here's my residuals, and I see a very wavy pattern. So this is also a pattern. That means quadratic is probably not what I want to go with for this set of data. Last model to try is the exponential one. So squiggle, AB, and then now the x is the exponent. Right. Now this looks pretty good by eye. Like the model line is really close to all the data points. I've got my A here, I've got my B here. Now let's check about the residuals, and here they are. You might say like it's a little bit wavy, and I guess yeah, but like I think in general like it's still like pretty horizontal, pretty flat. That's no pattern. Flatness is what you're looking for, something pretty flat. So I think of the three that I checked, this is probably the best one. Then the last thing that you need to be shown how to do is using your chosen model, predict the restaurant to grocery retail price for 2023. So I will show you how to predict something. To predict something, you gotta go with your chosen model. So mine is quadratic. Yours might not be. But since, mine is exponential. Yours might not be. But since it's exponential, I'm going to just take the exponential format, and I'm going to call this f of x. So it's an equation I can plug something into. And Desmos now knows the parameters a and b. So I can just type the model in like it's supposed to be. I don't need to type out these numbers. It's already known to Desmos. And then if I wanted to like make a prediction, like then my numbers are pretty small. So maybe I want to predict, I don't know, this point, like 0.2, because that's not in the data. There is no 0.2. It's somewhere between here and here. So the model at 0.2 is like 79, right? It's in the graph here, but I can also just use it to predict that. Okay, that's like the last question. And I think that shows you all the technical parts. The other questions are up for you to discuss and answer.